Hi, I'm going over the running marathon training needs analysis. I chose this topic mainly because I have a stronger background in endurance right now. As you can see, I'm a three-time Ironman finisher, three-time half Ironman finisher for the 70.3 distance, seven-time marathon finisher, and 18 and a half marathon for a half marathon, so half marathon finisher, as well as a three-time 100-mile finisher for cycling. So just to give you a little bit of background about myself for endurance. Now, most of the time that speaks more to the endurance audience because they like to see that you've been able to do and perform these actions. So that leads me to the next slide. So from an objective standpoint, what I'm looking to talk about today is the introduction to marathon distance needs analysis, as well as the biomechanical characteristics. The physiological characteristics are going to be discussed in a little bit of a shorter detail, and as well as the injury analysis and testing and assessment and the evaluations that would be used to determine a strength conditioning program for endurance athletes. Now for the marathon training needs analysis, which is the first step in designing and prescribing a resistance program. The marathon needs analysis will cover one, what major muscle groups need to be trained, what type of training should be utilized, and then what energy system should be stressed. In addition, what are the primary sites of concerns for injury prevention? The biomechanical characteristics of marathon runners. Running essentially is a repetitive series of single legged squats. So most of the time when you look at a runner, we think of runners constantly doing repetitive motions. However, those repetitive motions are in a single leg. So that's something to consider when you're thinking about analyzing this program in detail for injuries, as well as what muscles are being utilized. The plantar flexor muscles of the lower leg, such as the flexor ilicis longus, tibialis posterior, and flexor digitorum, which I've listed them just in a short, not long detail to give you an idea of how these flexors perform their action as well as the extensors. Give you a visual just of what those structures look like. To give you an idea, some of these structures are superficial to deep. From here, the quadricep group, which is your vastus lateralis, vastus intermedius, and rectus femoris and VMO. These structures are consistently utilized as well as overused during a running activity, where the hamstring muscles too, in addition, are your eccentric control. These guys are, as well as they perform a concentric action, your biceps femoris long head, the biceps femoris short head, as well as the semitendinosus and the semimembranosus. In addition, you have a series of adductor muscles, which adductor muscles not only adduct, but they also flex the thigh and they actually extend the thigh. So in addition to your primary hamstring muscles and your primary quadricep muscles, the adductor group of muscles flex and extend the lower leg in addition to adduction. The other biomechanical characteristics of marathon runners is the way these structures look. To give you an idea of the visualization for what these muscles look like, I've laid out a picture for you just to see the, let's say, pennation of the muscles, not necessarily too in detail, but just the angle of these fibers in a direction of them. Some of the key physiological characteristics of marathon runners is there is a high aerobic capacity. This aerobic capacity is known as VO2, which there is a submaximal VO2 as well as a maximal VO2, and these are observed at great variations. So research traditionally addresses the oxygen cost of running at submaximal velocities. So the submaximal velocity has several key indications to perform during the running bout. When you look at the percentage of muscle fibers used at that submaximal rate, 70 to 80% of the type 1 muscle fibers are your slow twitch or oxidative muscle fibers. 20 to 30% of those are type 2 muscle fibers, which are your highly glycolytic or fast twitch muscle fibers. To break those down into the three subtypes from the sub 2, you have a 2A, 2X, and 2B. This comes into consideration when you're thinking about utilizing those transporters to shuttle mitochondria from type 2 into type 1 to improve endurance or sustain a power output. Now, when you look at the type 2 fibers, which have the lowest level mitochondrial content and oxidative enzymes, we rely on the glycolytic metabolism as an energy source. And these muscles, as your type 2, are more susceptible to fatigue. So we'll transfer more of the metabolic, the mitochondria to increase the metabolic process. Then there's an oxidative contraction from the 2A and 2X fibers, which lie between type 1 and type 2B. And this comes more into detail when we're talking about the energy system utilization during the VO2 slow component and the VO2 fast component. So when you look at the additional characteristics, there are a number of things that occur which most athletes think of lactate. So we'll talk about blood lactate and critical power. So these assessments allow runners to develop training methods to sustain thresholds under the anaerobic work, which is W prime. Underneath that W prime, you're able to theoretically sustain a power output for a longer bout without tapping into, let's say, creatine phosphate and all these other storages to use additional funds or additional resources, really. And you're able to sustain a little bit longer. So the higher the energy requirement from VO2 lactate threshold, as well as your critical power and your VO2 max, these higher energy requirements are taxing, and they require the rate of oxygen to be shuttled. This is where we look at oxygen uptake kinetics, and that's really the movement of oxygen throughout the system. So the size principle also states that when smaller low threshold motor units fail to meet this power demand, larger higher end threshold motor units are recruited. This was written by Dr. Petit and Clark in 2013 to discuss how you actually can use type 1 muscle fibers to create and utilize power efficiently for a sustained amount of time, and how they actually do have an energy source. So marathon runners are at a higher risk of repetitive overuse injuries due to the inability to distribute forces. This is where ground reaction forces are discussed and how to efficiently distribute those ground reaction forces or dampen those ground reaction forces, which is what shoes are designed to do, but how to efficiently produce that muscle force contraction. And this is where we go into limited tendon stiffness versus a proper tendon stiffness to produce that stored energy component or series elastic component for the stretch shortening cycle, as well as the tendon stiffness, which produces more power output at the lower leg. There's a number of bone mineral density issues that occur in endurance athletes or marathoners, as well as relative energy deficiency syndrome, which has to do with the hormonal milieu as well as energy storages to provide energy to the working muscle, as well as provide hormonal movement to sustain or prevent bone tissue breakdown. Now, depending on the specificity of the group, novice, competitor, amateur, elite, whichever category we're actually talking about, running injury rates vary between 37% and 56% per year. Now, there's a series of types of running injuries that occur. So the incidence is calculated according to the exposure of running time. The running time varies per athlete. So a novice is not going to perform the same way a competitive athlete who is just looking to maybe qualify for Boston, or amateur, non-professional, but amateur does consist of somebody running a 550 per mile, which is just not somebody who's sponsored, and performs maybe 100 to 120 miles per week, where a professional runner may be doing the same average of 100, 120 miles per week. And this is where we start discussing about the elite categories and what time frame training volume equates to. So the incidence rate reported in the literature varies from 2.5 to 12.1 injuries per 1,000 hours of running. This is simply for the novice runners, which was a study performed to identify between a meta-analysis and a systematic review to determine the amount of hours ran that was reported by these athletes by Videbek, if I'm saying it correctly, and Videbek et al. So a number of leg injuries occurred through predominantly lower leg injuries through training. So this was identified in 7.2 to 50% of the injuries that were discussed in the Van der Wamp, this is funny because of the names of these, the Van der Wamp et al. Study that determined the running incidents that occurred by distribution was reported by these athletes. So another group of multifactorial running injuries that occur at the lower leg and foot have been distributed by Van der Wolf et al. As 9.2 or 9% to 32.2% of reported injuries are multifactorial, which means there's a little bit more of a complexity to those injuries. And how to determine how those injuries occurred would be looking at the ankle, knee, hip at the same time, but not necessarily putting it down just as one talocrural joint dysfunction type injury. Some of the less common sites of injuries would be the ankle, the hip, the pelvis, groin, as well as the low back, because they're distributed differently in how they report. So a person of low back pain, which is very common in society, would report that to a different provider, which was also discussed in Van der Wolf et al.'s reports, the lack of quality in reporting this information. However, the range is anywhere from 3.9 to 16.9%. We're looking at the testing and assessment. So there's a number of strength tests that we would utilize. However, to prevent an athlete as a marathoner from not wanting to perform a series of tests, as well as utilizing test specificity and tests that would be efficient for that athlete, we've selected 1 rep max, which would be used with the trap bar for safety concerns, mainly because most marathon runners do not lift certain type of like low, let's say 1 rep max loads or perform Olympic lifting. These are some of the complications in designing a strength test determined for strength of a marathon endurance or triathlete. So when we look at marathoners, another simplified test would be the 1 rep max barbell hip thrust, which Delgado et al. Determined that the gluteus maximus activity was higher during the maximal voluntary contraction of a glute max exercise. And as we've discussed in previous literature and information, endurance athletes or marathon runners have insufficient gluteal activity, specifically the glute max, which would be underdeveloped at certain type of fibers, the upper, middle versus lower, as well as how those positional movements would be performed to increase that hypertrophy of that type 2 muscle fiber. The group of structures that they do train are the glute med and glute min during a lateral band movement and stuff like that. So this is why we've chosen the 1 rep barbell hip thrust movement. The other thing is the pull-up test to determine a number of upper body strength, because most of the marathon endurance athletes would benefit from upper body and core strengthening, and a efficient, useful test that can be validated from a number of inexpensive equipment, not highly costed equipment, will be the pull-up tests. Now for the isometric hold, we've come to a conclusion to look at eccentric hamstring fatigue may be a potential risk factor. And the group of Kohler et al. Have developed or designed a simple, not a necessary test, but a simple method to look at eccentric hamstring exercises being integrated into their training. So eccentric hamstring training should therefore be introduced as an integral part of the training for runners. I've listed a picture off to the right of the device to use that, which is called a NordBord device to measure and analyze hamstring strength from an isometric contraction or a repetition type movement in terms of hamstring range of motion, whether you do the full range of motion or at 45 degrees utilizing isometric or repetition to identify which group and structures would be the weakest of that athlete. Now, testing assessment, which is a key performance indicator for marathon runners, is the VO2. This has been validated consistently, and it's a reliable measure for endurance athletes. So we would use one, running economy, which is a measure of the amount of oxygen they're utilizing during training to and sufficiently to the muscles, which is we're looking at stroke rate times heart rate times stroke rate. The cardiac output, heart rate times stroke volume. So here we look at lactate threshold as well as the velocity at VO2 max and critical power, which was discussed in the new book of sports scientists by Dr. Duncan French and Dr. Rhonda. So the testing assessment that is the most specific for marathons athletes, which would be utilization of data and data that is readable real time or data that is on the watch as in user friendly for us. So in theory, endurance athletes utilize wearable data trackers. This includes Garmin watches, Polar watches, Apple watches, and a pod, which is a Stride device pod, a foot pod that is utilized for critical power analysis, just to name a few, in addition to other running metrics, as well as the Moxie device, which is another device that can be utilized real time or pre and post. And those data analysis are critical to sports scientists as well as coaches and strength and conditioning coaches to determine how much volume an athlete is experiencing and able to tolerate. Passer et al. Also determined the validity of wrist-worn trackers. Now, this results in a little bit of a complication for which type of device the athlete would be wearing. So if the athlete is wearing a Garmin Forerunner 920 XT, which your Garmin tracking devices, this is the 935, would look something like that, or that one. There's a biometric scanner in the back, which you can see the beeping. The 920 XT, which is a separate model, because there's a number of types of Garmin devices that I don't want to talk too much about, but there's a number of types, significantly underestimates VO2 max. So there's a t-test of 23 personnel, ranging from male and female, with a negative distribution of 2.37 and a probability of 0.27 or 0.027, sorry. So the mean absolute percentage error that we experienced, or they experienced during the research study, was 7.3%, which would be the error of the mean of the groups. So when they compared another device, the average estimation between the Garmin, when you look at this, just the means of that Garmin device of those personnel who ran and did their VO2, would come up anywhere from 48.1, which standard deviation, or plus or minus 6.5 standard deviations from the mean, which would be a little bit higher. So ideally, you would get a large range from this number of 6.5. So the underestimation, if you put the calculation in there correct, you would be able to add in at 6.5 to get a closer estimation. Now, the Polar had no significant, and this is the Polar PV800, no significant tendency to overestimate VO2. And the T distribution of 23 personnel, put the number up there correct, it was a 7 actually. I have to change that probability. Um, which had looks like it's actually supposed to say a 71% probability. So the probability was higher on the PB 800. So there was a 13.2% mean absolute percentage error. And this was the distribution of VO2 displayed 53 milliliters per kilogram for oxygen. And the distribution from the mean was 10.5 standard deviations. So within that 10.5 standard deviations. So as you can see, the tested devices did show or did not show valid results concerning the estimation of VO2, and there was a standard error estimate um, throughout there that needs to be accounted for in utilizing that specific device. So going over any of the ways to determine a strength and conditioning program, we would utilize the analysis. So from there, the analysis would tell us, one, what injuries are we seeing? What type of groups of muscles are we going to actually strength train from those injuries based on what injuries we'd have, as well as our main focus for tests pre and post. And this is how we'd help to develop a strength conditioning program for marathon athletes. So these are my references that were utilized. Thank you. And that concludes the talk.